So we saw this same list when talking about triggers. But as you can see, there's a lot of work that takes place inside of a transaction. And it's critical for performance that we want these transactions to be as tight as possible. So when you're planning your transactions, you want to make sure that if you can do your work with a nullability constraint instead of a trigger, or with a check constraint, that's what you want to do instead of putting the code inside of a trigger, because you want to keep these transactions fast. The transaction log, or T-log, also called a write-ahead transaction log, is really important for the durability of a transaction, and it's fundamental to how SQL Server works. So let's walk through what happens for a transaction, looking at the pages in memory and the transaction log and the data file and those types of things. So step number one is that the data file, the database, begins in a consistent state, and that's the C part of ACID. A user comes along and within a transaction says begin transaction and update. Following step 3 with the update, there's a whole lot of work that takes place as far as checking all of the constraints, running the triggers, those types of things. But in the end, the data is written to the data page in memory. And notice that the data page probably already started out in memory because the memory buffer does such a good job of preloading pages into memory. SQL Server then also takes that change and writes it to the transaction log. Once it's written to the transaction log, SQL Server does a special type of write through Windows such that Windows confirms back that it was written to the hardware and the hardware confirmed it was an OK write. So SQL Server has the confirm automatically through Windows and knows the transaction log has been written to, and that's very important. So now in memory, SQL Server writes to the data page and says, yes, now we know that this update has been written to the transaction log, and that's step number 7. Then the commit takes place. When the commit happens, that commit is then also written to the write-ahead transaction log, so it knows that this transaction has not only been written to the memory, but has also been written to the log, and that's step number 9. And just like the previous write to the transaction log, it's confirmed back from SQL Server. So now we know through the transaction log that this is a write that has taken place and it's been confirmed. With the change and the commit written to the transaction log and written in the data pages in memory, the data is, in essence, in a consistent state. At some point in this process, the lazy writer or one of the other threads will come by and check this data page and see that the data page is dirty. It has been changed. And that data page will then be written to the data file. If SQL Server happens to crash, loses power to the server, or something bad happens, as long as it's been written to the transaction log, when SQL Server boots back up and does its recovery process, it'll check the transaction log, check the data file, and any transactions that need to be finished in the data file will be completed. Any transactions that were written to the transaction log but not committed will go ahead and be rolled back if they were partially written to the data file. So it's this write-ahead transaction log that allows SQL Server to have durability for the ACID property compliance.